My mini project is on least significant bit steganography. This is the art of hiding data within a cover image or audio in the least significant bit, a type of security through obscurity in which you hide the message that nobody but the recipient and the sender is aware of its existence. This operates on the principle that the human eye cannot distinguish between two shades separated by only one bit. An index bitmap image is composed of two matrices: the CData matrix, which is composed of unsigned 8-bit integers, and a color map. Characters can be represented with 7-digit binary numbers. We strip the least significant bit from the CData, then replace the least significant bit in each pixel with 1 bit from our message. To encode data into an image, first you turn your message string into doubles. Then use d2bi to create a matrix of binary digits which correspond to these doubles. The first element of the cover image CData is set to n times 7. Now you subtract an integer from 1 to 8 from the second element to indicate which bit is used. Then strip your chosen bit from the other pixels using the modulus function and add each element of the binary vector to an element in the cover image. To decode an image, you read the first two elements to determine the length of the message and which bit to decode, then use the modulus function to strip that bit. You use this data to populate a matrix in which the number of elements is the same as the first element in the CData. Use bi2d to convert this matrix to a vector of doubles, then cast as characters to get your string. We use the least significant bit because human observers are unable to distinguish between the original image and the encoded image. The pixels of the encoded image will be at most one value separated from the original. If you use higher bits, however, severe degradation of the cover image occurs, defeating the purpose of encoding. Here is the key image which we will be using for the following example. This is a key image encoded with a 10,000 character string on the least significant bit. Here's the same image encoded with the same string but on the most significant bit, and as you can see, severe image degradation has occurred. Can this withstand compression? The short answer is sometimes. Compression tends to most affect the least significant bit, which is where we have hidden our message. A bitmap, which is uncompressed, keeps all of the data that you encode in it. A JPEG, which uses lossy compression, loses most of the data and obscures the rest of it. A GIF, however, which uses lossless compression, maintains all of the data while still compressing the cover image. If we want to hide an image within an image, we can also do this with the same principles. There are some restrictions, however, such as the cover image must be greater than 8 times the size of the hidden image. On the left is the original image, in which we'll hide the image on the right inside. This is that same image, but now with the other image encoded within it. On the left is the original image, and on the right is the image which we decoded using photo-decode, our function. To increase security of this, we could encrypt data before embedding it, embed it randomly rather than sequentially, or embed data in the frequency rather than the spatial domain. For increased capacity, we could embed multiple bits per pixel, which would degrade the image further but allow us to hide more data, or compress data through a reversible, non-lossy method prior to embedding. The sources for my mini project are as follows.